So the physics definition of a gradient is an increase or decrease in the magnitude of a property, like temperature, pressure, concentration. And in the case of machine learning, and specifically in the case of linear regression, it's the magnitude of the property describing the error, right? And so observed in passing from one point to another. When I think of gradient, I think of this picture here of the predator. We have an infrared camera. The heat signature is high here in the heart. It gets lower as you move away, and then black is when temperature is the lowest, right? So we have a gradient here, which is going from a high value to a low value. And so when we are thinking in terms of our model here, right, what we have is a line, which is the model that is proposed by the linear regression algorithm, and then it uses the least squares method in order to figure out the amount of error that that model or that line has associated with it, right? And a line can be described as mx plus b, right? Y is equal to mx plus b, where y is the dependent variable. We know this, right? And what we're trying to figure out is that slope and that y-intercept that will minimize the amount of error, right? And so what do we need to do? Well, we need to minimize the error, right? And so if we go ahead and take a look at a 3D representation of the error given a y-intercept and given a slope, right, you could see here that it maps out a 3D surface. Okay, so for any y-intercept and any slope, and basically a y-intercept and a slope is a line, right? So you could see here that if the y-intercept is 3 and the slope is 2, then the error would be, and I'm just guessing here, would be 2. Okay. And then if the y-intercept is 1 and the slope is 3, and again I'm guessing, then the error would be 1.5, right? And so for every fraction of the y-intercept and every fraction of the slope, we can, draw a dot for the error, and it would create this surface. Okay. And so what is gradient descent? It's taking the function that describes the surface or describes the error, which is essentially describing this surface, and we're minimizing that. We're finding the value for y and the value for m for which the error is the lowest on this graph, right? Whether that's 1, whether that's 1.3, right? That's what gradient descent is doing. It is finding the value for y and the value for m, which is essentially finding the line that minimizes the amount of error using all of those data points that we had, right? And how does it calculate the data points? How does it calculate the error? It calculates them using the least squares method. And so we learned earlier that in order to a way that we can figure out the minimum of a function, which the error can be represented by, we can use the derivative, right? And the derivative will tell us which direction to go in, right? If the slope is going this way, then we need to move to the left this way, right? If the slope is going this way, then we need to move to the right to get to a lower point, right? And so that's how gradient descent works. First, it creates a function for the error, and then it uses the derivative of the y-intercept and the slope in order to know which way the y-intercept needs to be changed and which way the slope needs to be changed, adjusted by a little bit in order to recalculate the error, right? And so I don't know, that might have been too big of a leap for you, or it might have been okay. Hopefully it's okay. And if you have any questions, you can ask away. But that's essentially what gradient descent is. In the next video, we're going to talk about how it's calculated mathematically, and then the following video we're going to see how it's coded.